So let's talk calculus. But is calculus scary? No, I don't think it is. I think calculus is misunderstood. I think a lot of calculus depends on whether or not how well you know your algebra. But luckily, we're going to be talking algebra today. So let's go ahead and get started. So let's start by evaluating. Let's talk about limits. So what is a limit? A limit is is a value that a function approaches. So it doesn't actually matter what the function at a point is. All that matters is what the function approaches. So let's say, for instance, I'm going to draw a little graph. For some reason, that pen's not going to work. So luckily, I have a few. Let's go ahead and draw a graph. I'm going to draw a random function. Here we go. So we never did it. Welcome to the world of calculus. Right. So a limit, all it cares about is what y value we approach at a certain point. So I'm gonna mark this as point A. And the limit tells us, okay, as x approaches A, what does y approach? So if you notice, I'm gonna go in both directions. I want to approach A from both the left and the right. So I'm gonna follow the function from the left. And I notice as I approach A from the left, it's going to approach this open dot right here. If I follow along from the right, it's also going to approach that dot right there. So we say, I'm going to call this B, and I'm going to call this C. So we can say that the limit as x approaches A, oh, this is f of x, by the way. The limit as x approaches A, is going to be what value? Well, if we approach from both the left and the right, it looks like it's approaching B, so the limit is B. However, if I want to find f of A, well, f of A is not this open dot here. It's actually this closed dot right here. So we say that f of A is equal to C. So sometimes we're going to see that the limit of a function doesn't actually equal what the value of the function is. Yes, knowledge is a very good thing. The more knowledge we acquire, the better. So so now that we know that, let's go ahead and find some limits. So when I want to find a limit, I write this. I write the limit, lim, as x approaches something, which I'm going to call a. It's too high up your paper. Okay, is that better? I want to get smart. Absolutely, we all do, and that's why we watch these streams. So when I approach some x value a, that tells me, okay, that's the point of interest. That is the point that I want to look at, and f of x is our function. So now that we have a graphical idea of limits, let's go ahead and work on some. So I'm going to start with this first problem. Let's find the limit as x approaches 3 of x squared. So what I'm going to do here, so my first step when we solve limits, my first step is to plug in my value here of here into x directly. And it's going to show us either one of two things. We're either going to find that we can just plug in and get our answer, or sometimes we're going to have to do some algebraic gymnastics to make it work. So in this case, let's see what happens when I plug 3 in for x. So this is going to give me 3 squared, and 3 squared is 9. So we say that the limit as x approaches 3 of x squared is 9. So the two rule. So as far as things to avoid, we need to avoid the following two things. So things to avoid. So first, we want to avoid anything that causes division by 0. By 0. Because anything when we divide by 0, things get crazy. So the second thing as well is a negative inside a square root. Inside the square root. So anything that causes one of these two things means that we're gonna need to do some work. This is better than gaming live stream. I fully agree, Alex Norberg. I fully agree indeed. So especially when we talk division by 0, sometimes we're gonna see stuff like we're gonna see limits result in 0 over 0. This is called indeterminate form. I have to think about how to spell it because even to now I still get the spelling wrong. So it's indeterminate form. So indeterminate form basically means um that we have something that can't happen. Like we can't have 0 over 0. If we ever run into this, and we're going to run into 0 over 0 a lot when we do limits, then that means we need to do some algebra or maybe some trig or whatever can help us get rid of 0 over 0. So let's go ahead and try another limit. So I'm going to find the limit as x approaches 6 of 3x squared minus 2x plus 7. What do you think that's going to get me? Or what do you think the limit will be? Hey, Audrey, what's going on? Great streamer. Oh, great live earlier, by the way. Not sure. Okay. That's okay. Are we going, what will this limit be? You're welcome, Audrey. What do we think about this limit? 103. Okay. Now, what do we get? Hog Champion says 103. What else do we get? Audrey says 103. people another minute to answer, and then we will go ahead and find this limit. So while we're doing that, I realized earlier I forgot to actually introduce myself, so I'm going to do that right now. So hi, I'm Robert, the AP Math guy. I am from the great state of Maine. I know it's probably a state not a lot of people know about. In fact, I get the aren't where is that in Canada? A lot. And no, believe it or not, I'm not in Canada. I'm in the United States. But we're pretty close to Canada. I could drive to Canada if I on for a day trip. Um, Thank you to everyone liking this live and following and and sharing. So let's go ahead and evaluate this limit. So my first step is plug in 6 everywhere I see an X. So let's go ahead and do that. So I get 3 times 6 squared minus 2 times 6 plus 7. I don't see division by 0 or a negative inside the square root. So that means that I'm not going to, that this will just get me the answer. So 6 squared gives me 36. And not an equal sign, minus sign. 2 times 6 plus 7. 3 times 36. That's going to be what? That's going to be 1. Oh, wait. Minus 2 times 6 is 12 plus 7. 108 minus 12 gives me 96 plus 7 equals 103. So that is my limit. Should probably move this a little bit. Yeah. So yeah, unless we run into one of these two things, we're gonna go ahead and we will normally just plug it in and see what we get. Right, all right. So let's go ahead and move on to the next one, unless anyone has any questions on that. So let's find the limit as x approaches 2 of x squared minus 3x plus 6 all over x minus 1. So here I have a fraction. So that means I have to think about if division by 0 is going to happen. So that's the question. Will we see division by 0 here? Yes or no? Audrey says no, right? Thank you, Bridget, for the likes. Og says 4. Okay. So yeah. So if I plug in 2 for x here, I get 2 minus 1. So that's gonna 2 minus 1 is 1. So that means I'm not gonna worry about division by 0 here. So what let's plug in two. So that means I can just plug in 2 and see what my answer is going to be. But what would the answer be since we can't have division by 0? Audrey says she agrees with Pog. Okay. Oh, correct. I told you, isn't autocorrect just wonderful? I know sometimes I'm writing words and I end up sending something that's not even close to what I actually want to say. It's like, thanks autocorrect. Thanks for nothing. Welcome, Ahmedreza. I hope I'm pronouncing your name correctly. I apologize if I'm not. But Ahmedreza says four. Welcome everyone joining in to this amazing first live. Audrey says four. All right. So let's go ahead and find this limit. So what I'm going to do is I'm going to go ahead and plug in. So since we've already established that we can't have division by zero here, what I'm going to do is I'm just going to plug in 2 and see what happens. So I'm going to have 2 squared minus 3 times 2 plus 6 all over 2 minus 1. Good job, me. Yes, let's tap to 10K. All right, so 2 squared is going to get me 4. Minus 3 times 2 is 6 plus 6 all over 2 minus 1, which is 1. So 4 minus 6 gives me negative 2. Plus 6 is going to bring it right back to 4. Divided by 1 is going to give me 4. Oops. I have to keep thinking. I have to remind myself that I need to move the paper as I continue working. I'm so used to having a larger board and just being able to write and write and write that I have to remind myself now that I need to move this paper around so that way people can actually see. Cool. Yes, Audrey, I will get you. I'm sure I will get used to it. Must be those first use column approach. Do you mean like writing in a column, Og? Hey, please join you as a guest in the live. Um, I think I'm gonna do this one solo. I think I'm gonna do this one solo, but maybe in a later one, maybe in another one. Yeah, fair enough. I will be sure to do that. Actually, let's do that for the next one. So I want to find the limit as x approaches 0 of x squared minus. Actually, let's make this x cubed. X cubed minus 2x squared plus x all over x. So if I plug in 0, what am I going to get? What do I get when I plug in 0 for x? Audrey says 0, right? Hey, Chaz, what's going on? Factor out x and cancel it. Okay. What happens if I plug in 0? X says undefined. All right. So if this function is, so why would this function be undefined? Or why would it be undefined? Be undefined because, well, let's plug in 0 and see what happens. So I get 0 cubed minus 2 times 0 squared plus 0 all over 0. So immediately, the thing I notice is this 0 in the denominator, and we can't divide by 0. So we now have an undefined point here. But just for fun, let's see what happens when I solve the numerator. So I have 0 cubed, which is 0. 0 times 2 times 0 minus 2 times 0 squared is 0. 0 plus 0 is 0, so I get 0 over 0. And remember that 0 over 0 is the indeterminate form. So that means that now that I have 0 over 0, it means that I need to do some algebraic gymnastics. So, as Pog said, what happens if I factor out the x? So let's try that. So I have a limit as x approaches 0 of x times what would be left in the numerator when I factor out an x? Can fit two vertical columns, by the way. Okay, good to know. Good to know. Bridget says 1. When I factor out an x, what am I left with? I'm left with x cubed divided by x gives me x squared. Negative 2x squared divided by x gives me minus 2x. And x divided by x gives me 1. So then I have an x in the numerator. Yes, Audrey, that's right. So I have an x in the numerator and an x in the denominator, so I can go ahead and cancel those. Now I am left with the limit. Let me draw a little arrow up here. The limit as x approaches 0 of x squared minus 2x plus 1, which means now if I plug in 0, I don't have to worry about division by 0 anymore. So I can just go ahead and plug that in. So that gives me 0 squared minus 2 times 0 plus 1. 0 squared equals 0. 2 times 0 is negative 2 times 0 is 0. So I have 0 minus 0 is 0 plus 1 gives me 1. That's it. It would be our limit. we can see here that what value we approach doesn't necessarily equal the value at that point. So what would that look like if I had function approaching one, approaching zero being in indeterminate form, but if a limit exists, it would look like something like this. So here's one. So highest power. So this would probably be a parabola. Here's zero. I don't care about one. So it would probably look something like this. That's correct, Audrey. To summarize, if you get zero over zero, you'll have to do some algebraic gymnastics, but it's not always going to be factoring. Sometimes you'll have to multiply by the conjugate, which we'll get to in a little bit. Sometimes we'll go into trig, knowing our trig laws, which is why it's important if you're planning on doing this higher level math that you be familiar with your trig identities. Especially, I think the unit circle is the most important part of trig that you would want for this. So yeah, indeed. All right, so let's go ahead and try another. And I am at the end of a page, so I will go ahead and turn this over. Cameras, there we go. So let's try another one like that. Let's try the limit as x approaches 4 of the following. X squared minus I minus x minus 20. Let me rewrite that as x over x minus 4. So what would this limit get me? Or what would the limit be? And even if you put a question mark, that's still an answer as well. All right. Pog says factor first. If I were to factor, what would I get? Thank you, Lovely, for the roses. Thank you, Chaz, for the tiny diny, and thank thank you, Audrey, for the. I think that says you're awesome. Sorry, I didn't see those earlier. It's just math can be so exciting that sometimes I just forget to pay attention to anything else. Yeah, so what happened? So what would this limit be? Og says plus x? Question mark, question mark. Okay. Oh, minus x. X squared minus x minus 20 for x minus 4. Yeah, so if it were plus x, if it was a plus x, it will cancel out. You're right. Let's make that plus x. Which it says with negative x, negative 8 over 0, with plus x, 0 over 0. Log says 9. Bridget says time for some algebraic gymnastics. There's always time for algebraic gymnastics. I'm shocked it's not an Olympic sport at this point. I mean, we have regular gymnastics in the Olympics. Why not algebraic gymnastics? Yeah. So if I were to plug in 4 right now, I would get 0 over 0. So we can't have 0 over 0. So that means that I have to factor the top. So let's go ahead and do that. So if I want to factor the top, what does the top factor to? What would the numerator factor to? We lied. Okay. Right. Oops. That actually is a lot. That's actually a little better. I am definitely doing some experimenting today. So if I were to factor the numerator, I would get x minus 4. Bridget says x plus 5, x minus 4. Yep. So I would have x minus 4 and x plus 5 all over x minus 4. So here, x minus 4 and x minus 4 cancel, so those go away. So I would be left with the limit as x approaches 4 of x plus 5, which means now I can plug in 4 since the whole division by 0 thing is gone. In fact, when it comes to these x plus 4s, we can almost say bye 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 to them. So that means now I have 4 plus 5, and 4 plus 5 is going to give me 9. That is my limit. Og does rule, indeed. So yeah. So even when even when we have functions like this that um look like it's not, it doesn't have to be no, let's go ahead and ramp up the difficulty a wee bit. So let's find the limit as x approaches 2. Do let's do this. Let's do x minus the square root of 4 all over x minus 2. So can I plug in, or am I gonna have to do some algebra? When I plug in when I plug in 2, so Audrey says algebraic gymnastics. All right. Hug says 0 over 0. All right. So yeah. So if I plug in 2, let's see what happens. So I have 2 over the square root of 4 all over 2 minus 2. So if I have 2, so when we take the square root, we only care about the positive square root. At least when we're taking limits, we only care about the positive square root. So that would be 2 minus 2 over 2 minus 2, which would get me 0 over 0. But we can't have 0 over 0. So that means we are going to indeed do some algebraic gymnastics. What we can do is we can employ something called the difference of squares to solve this problem. So, in case you don't remember what the difference of squares is, that means that if I have a squared minus b squared, then I can factor that as a plus b times a minus b. So if I want to, so to do, since since I want to do this, I'm going to go ahead and do it here. So I want to get rid of that square root. So what I'm going to do is I'm going to multiply the top by what's known as the conjugate. And all the conjugate is the following. I'm just going to keep my x and I'm going to keep my root 4. But instead of a minus sign here, I'm just going to switch it over to plus. And remember, what I do to one side of a fraction, I have to do to the other. So I'm going to go ahead and do that to the bottom as well. Hey, Michael, what's going on? Multiply by the conjugate x plus 2. Right, that's right. So I could simplify root 4 as 2. So let me do that. I am I'm kind of doing that too. But anyway, so I have, actually, let me write it down here. So I have limit as x approaches 2 of x squared minus 4 all over x minus 2. And from there, I can use this difference of squares to factor that. So that gets me x minus 2 times x plus 2. But I also have that on the bottom too. X plus 2, x minus 2. X minus 2 cancels, and the x plus 2's cancel. So now I just have the limit as x approaches 2 of 1. And the limit as x approaches any number of a constant is just that constant. I think I actually wanted to go the other way, but that's okay. It's good to show that as well. So let's see what happens when I when I put the x inside the square root. Limit as x approaches 2. Or actually, x approaches 4 of 2 minus root x all over x minus 4. So here, if I plug in 4 for x, I get 2 minus 4, which is 2, all over 4 minus 4, so that gives me 0 over 0. So let's go ahead and do some algebra. So the limit as x approaches 4 of 2 minus root x all over x minus 4. Actually, this is a good one to show anyway. All right, so what I'm going to do is, again, I'm going to multiply by the conjugate of the bottom. It's going to be x plus 4 and x plus 4. So on top, I'm going to leave the top alone. Actually, is that going to matter? No, it's not going to do anything. Okay, so let's continue this out anyway. So sometimes what's going to end up happening is sometimes we can't evaluate the limit. So no matter what we do, two minus root x over x minus 4. So sometimes how do I want to do this? So can solve this. It would require but it may require derivatives. I think of all the algebra that we can do to this. Don't think there's anything. So if I multiply, no, I still won't get rid of that. Okay, so we'll save this one for later. So actually, well, I want to try to do it anyway. I2 plus Rx. Okay, let's try that. So we multiply by 2 plus root x over 2 plus root x. That's going to get me 4 minus x over x minus 4. So yeah, so then from here, I could just factor out -1 from the denominator or the numerator. Let's do that. 4 minus x all over 1 times 4, or -1, 4 minus x. Yeah, the 4 minus x's cancel. And now I have the limit as x approaches 4 of -1, or 1 over -1 is going to be -1. That's right, Pog. Cool. Okay. Any questions on that one? Let's reach 20K. We have 3K left to go. I'll do the next problem when we hit 18K. When we hit 18K, you tried multiplying top and the bottom. That's what I originally tried. That's what I originally tried as well up here. But when I do that, it doesn't get me anywhere. -1 over 4. Nope, because the second I remove um the second I removed this 4, I canceled out this 4 minus x. There were no more x's to plug in. I messed up. I did mess up. Why? Because I forgot to multiply the bottom by 2 root x as well. So what happens when I have that? 2 plus root x, limit as x approaches 4 of negative 1 over 2 plus root x would be 1 negative 1 over 2 plus root 4, which would be negative 1 over 2 plus 2, which is negative 1/4. You're right. You are completely right, Pog. Let's try another one. So I'm going to flip over because I have used that paper. Let's find let's find this one. Let's find the limit as x approaches 0 of the square root of x plus 5 minus root 5 all over x. What do we end up getting? What would be our answer? 20k, let's go. Og says conjugate the top. Okay. Og says 0 over 0 again. And Sal's giver 789. What's going on? No. So let's try multiplying by the conjugate. Or first, let's see what happens when I plug in 0 for x. Well, this 0, this tells me that I'm going to end up with 0 versus this x in the denominator tells me I'm going to end up with division by 0. So I can't do that. So what I'm going to do instead is, yeah, I'm going to go ahead and conjugate by the numerator. What would the conjugate be? X says x. That's awesome. Thank you, Audrey. Glad to see you join. Glad to see you hear it. And Giver. And thank you for the follow. What would the conjugate of my numerator be? I I will definitely try. Um, I'm definitely experiencing those first live nerves right now a little bit, but I'm sure those will go away as time goes on. Thank you. I really appreciate that. Audrey says negative x. Okay. Remember that the conjugate keeps my two terms in keeps my two terms, but just flips the sign in between them. Would be root x plus 5 and root 5. I had a plus sign there. We don't use the denominator. No. So the reason I don't want to use the denominator is, well, let's see. So I have x plus 5 plus root 5. Using difference of squares, I would get x plus 5 minus 5 all over x. Well, and then 5 minus 5 gives me 0. The limit would, so that would leave me with x over x. But I can cancel those x over x's. I can cancel the x's since they're both in the numerator and the denominator. So that would leave me limit as x approaches 0 of 1, which would be 1. Limit is 2 over. I did it again, didn't I? I did it again. You're right. Definitely. I can't believe I'm doing that. So that's wrong. So x over x times square root of x plus 5 plus root 5. X's cancel, which means that I'm going to have 1 over the square root of x plus 5 plus root 5. Now I plug in 0, get 1 over 0 plus 5 plus root 5, which equals 1 over root 5 plus root 5, which gives me 1 over 2 times root 5. That's it. Nope. If there's one thing I'm showing today, it's that I can definitely make mistakes. But I'm glad to hear that, Audrey. Yeah, so the reason why we don't multiply by negative x is because it wouldn't accomplish anything. But yeah, so that ends up being our answer. Cool. point, I'm shocked. Those are the only mistakes I've made. Okay, Audrey, thanks for hanging out. I think we'll do one or two more, and then we will call it a live. So let's go ahead and try another one. And this time I will be sure to pay attention to what I am doing because I do not want to yeah. Anyway, let's do one. We'll do one or two more. The limit as x approaches 9 of x minus 9 over the square root of x minus 3. Plugging 9 in, I'm going to get 0 over 0. Did I drink too much caffeine? You have the jitters. Uh, Surprisingly, no. I haven't had any coffee today. The only thing I have in front of me is water. Um, I think, like I said earlier, I think it's just first live nerves. Hog says conjugate the bottom. Yeah, let's go ahead and conjugate the bottom. What would that conjugate be? Hey KG, what's going on? Saw you in here earlier. What would the conjugate of the bottom be? Hog says root x plus 3. Yeah. So if I were to multiply both by the square root of x plus 3 and limit as x approaches 9 on top, I'm going to make sure I do it this time. Michael says square root of x plus 3. Yeah, I'm going to make sure I remember this time. Root x plus 3 over root x times root x gives me x, and 3 minus 3, negative 3 times 3 gives me 9. Hog says limit is 6. Let's see if you're right. So I'm going to go ahead and cancel out an x minus 9. And so I'm left with the square root of x plus 3. Now if I plug in 9, I get the square root of 9 plus 3. Square root of 9 is 3, and so 3 plus 3 gives me 6. So you're right, Pog. Good job. I think I got it right. Cool. Right, let's see if we can get to 23K. And then I'll do one more and then I will do my outro and we will yeah. And yeah, as time I feel like as time goes on, the I'll be more I'll be more or I should say I'll get better at being live. Those of you who just joined in, welcome, welcome. So we're at 23K, so we'll go ahead and do one more. So I want you to find limit as x approaches 3 of the following. Let's find the limit as x approaches 3 of x squared plus 2x minus 15 all over x minus 3. Mark says the limit is 8. Michael says the limit is 8. Right. Let's see what happens. So if I plug in 3, I get 3 squared is 9 plus 2 times 3. Well, 2 times 3 is 6. 9 plus 6 minus 15 is 0. And 3 minus 3 is 0. So I have 0 over 0. So let's go ahead and factor that. Well, I can factor the numerator. Two numbers that multiply to 15 and add to 2, or negative 15. I will go ahead and do it this way. It says 5 and negative 3. I don't have a fancy I unfortunately don't have a fancy factor chart, but yeah, so it would be 5 and negative 3. Let me make sure I include the x minus 3 down at the bottom. So I have x minus 3, x plus 5. Well, the x minus 3 and x minus 3's cancel, so we can say bye, bye, bye to those. And so I'm left with the limit as x approaches 3 of x plus 5. So now I can plug in 3 without having to worry about that division by 0 anymore. So 3 plus 5 is going to be 8. So yeah, so that is how we evaluate limits using algebra. We can use other methods as well, and I'll probably get into those event later on. But for now, I think that is all. Those are all the examples that I have. So I'm going to go ahead and end this live. But before I do that, I'm going to show you all. I'm going to give you all my small little bit of info. So here is when I go live. Actually, let me move my camera on up so that way you can see more of it. So I'm going to go live every weekday from at 3 o'clock. And then if you want to follow me here, this is that. And then also I offer online math tutoring. I offer both one-on-one and group tutoring. So if you're interested in that, you can you can message me on here. And with that, I think that is going to be this is going to wrap it up for stream number 1. Thank you all for watching. I really appreciate this. Um Actually, you know what? Let's see if we can get to 25K before we go. So yeah, um this was definitely a learning experience for my first live. And I promise I won't always have this much jitters. It's just going to be for the first one, maybe the first couple. But anyway, like I said, I'm sure as time goes on, um, yes, first live done. I fully agree. Yes, so I'm glad. I'll be honest. I'm kind of glad I'm done. But you know what? It was fun. I had fun. I hope you all had fun too. Even if it was laughing at me making mistakes. But that's the thing. Even those of us who have done math for a long time make mistakes. As you can see, even I'm still no stranger to making a mistake. So so I make mistakes. So don't ever be afraid of making a mistake in math because let's face it, we all do. Um, the most important thing is that we learn from our mistakes and we keep trying because math is great. It's not worth giving up on. But yeah, so we are at 25K, so I'm gonna go ahead and end it here. Thank you again, everyone, for showing up. And I will see you. Am I on the East Coast? Yep. Oh, I am on the East Coast. I'm from the great state of Maine. Well, I am indeed on the East Coast. But yeah, so I will see you all tomorrow, 3 o'clock. Have a great rest of your day, everyone. Now I need. There we go.